Hello everyone, my name is Spencer Keene and I am an applications engineer here for 3D Systems. Today's webinar we'll be talking about long-range modeling from point clouds. Why model long-range point clouds? Well, the end goal is to get into a CAD environment. Once in the CAD environment, we can qualify as-built floor plan creation, documentation of equipment and services locations for planning, plant and facility equipment replacement and refurbishment, historic architectural and artistic preservation, and other large-scale applications. In order to achieve our solid or surface model, we can go a few ways, one being prismatic modeling. Prismatic modeling, you can use a plane to take a section of the point cloud, and on that plane, you can create a sketch that can later be extruded, revolved, or lofted. Another tool that we have in Design X is the pipe wizard. By selecting polyvertices on the desired pipe, the pipe wizard intuitively creates the desired geometry. Today's webinar agenda is first we're going to import data. Then I'm going to show you the view clipping tool, which will be very essential here because we're going to be modeling stuff on the floor and then also the pipes on the ceiling. We're going to talk about scan registration. I'm going to show you how to combine multiple point clouds. We're going to talk about filtering noise. We're going to do a little sampling where we're going to drop the point cloud size. We're going to separate the point clouds. We're going to create reference geometry for our alignment purposes. We're going to do a mesh sketch, and then I'm going to show you the pipe wizard. Now that we're in the Design X environment, let's import some files. I'm going to go to the Import tab and open it up. But first, let me show you all the files that Design X supports. Design X, being scanner agnostic, supports a lot of hardware companies' files. As I scroll down, you might recognize a few. We support an E57 file, which has been standardized by ASTM, or also known as the American Society for Testing and Materials. Okay, now let's import some files. I'm going to highlight the bottom one, hold Shift, highlight the top, and all of them will be selected. When I hit import only, I'm going to be prompted for this full range import, which basically means I can set a value and data further than that value will be clipped out. Or if I set it as 0, all the data will be imported. Now that the scans have been imported into Design X, we're going to talk about scan registration. Scan registration is usually accomplished in other softwares like Cyclone or Scene. But in Design X's Alignment tab, under the Scan to Scan group, we have sphere registration and target registration tools. The sphere registration command roughly aligns point clouds by matching target alignment spheres. Couple of reasons for use are: one, combining multiple scans that are too large for one scan. Another being combining multiple scans that require the use of target alignment spheres. The target registration command aligns scan data automatically based on the target information of the scan shots. It checks a specified data folder for scan shots as they are created and imports and aligns data in real time. Scan data can also be aligned to either nominal target points or other scan data that has corresponding target points. In this instance, normal pick point is also fine. But after the scan data has roughly been aligned, then you run the Global and Fine tool, which aligns scans based on geometric feature shapes with the lowest amount of deviation possible in overlapping areas. Since this data has already been registered in Pharaoh's Scene software, what I want to do now is I want to combine these point clouds. As I said before, I have 9 different shots, so I want to make that one. I'm going to go into my points tab. I'm going to go and open the Combine tool, and I'm going to say point clouds here, which is going to select all of them, and I'm going to say remove overlap region. and I'm going to let this run. Now that the 9 point clouds have been combined into one point cloud, I can come over to the Properties tab under Polyvertices Count and see that I'm roughly working with 230 million points. I definitely need to bump those numbers down. It's going to help the modeling process go more smooth and a lot faster, and it's also going to reduce file size. I can achieve this a couple ways. One being filter noise. The filter noise tool removes unwanted noisy clusters from the point clouds. You can control the number of points in the cluster. For this demonstration, I will be doing that manually, so I'm going to exit out of this tool. I'm going to hide the planes. I'm going to bring up my polyline selection tool. So this is going to select the main portion of the body here. And once that main portion is selected, I'm going to do an inverse selection. And I achieve that by right-clicking in the scene and going to Inverse Polyvertices. And now you'll notice that all the noise is highlighted. Now I hit Delete. Now that the noise has been deleted, I'm going to have to sample the point cloud. I'm going to go up to the sampling tab. There's two ways to sample a point cloud. One is uniform ratio, which reduces the number of polyvertices uniformly by the ratio of the polyvertices. During uniform ratio, I can give the point cloud a specific value. For this demonstration, we're going to do uniform distance. Uniform distance reduces the number of polyvertices so that polyvertices are uniformly arranged by an average distance. This method removes redundant polyvertices and constructs a grid-type point cloud. And let this run. Now that we have the point cloud sampled, we come over and highlight it, come back over to Polyvertices Count, and notice that now we're roughly working with 35 million points. Our next goal is to align the point cloud to the world. And how we're going to do this is by making perpendicular planes. But in order to do that, we have to set a view clip. How I'm going to do that is orient the part, make sure select through is on, come in here and highlight the bottom portion of the point cloud. If I right click in space, I can say set view clip from selection, and now you notice I can see the floor area. What I want to do now is go into the display tab and turn off the texture. Okay, now let's make some planes. I'm going to go into the model tab. I'm going to open up the planes. I'm going to come into extract. I'm going to get my paintbrush. And I'm going to start making the Z plane. Each one of these selections is a ton of points, so you don't have to really paint the whole floor. We're just trying to get an average. We have best fit selected. So let's have a little preview. If we preview, that looks pretty good. Let's accept that. Now we need an average plane going through the middle. How we're going to accomplish that is by getting two planes, one on each of these sidewalls. Preview. Looks good. Let's accept. Come over to this sidewall. Grab some points. Preview. Hit accept. Now we're going to come in and say we want to find the average of two planes. Plane 3. Plane 2. And we have a preview of a plane going down the middle. Accept. Now for our last plane, we need this back wall. We're going to go back to extract. Paintbrush is on. Let's collect some data here. Hit preview. And accept. Now let's go into our alignment tab in an interactive alignment. We're going to say our moving entities is our point cloud. And we're going to do a 3-2-1 alignment. We're going to enable our view clip here. And our plane's going to be plane 1. Our vector's going to be plane 4. That was the average plane. And our position is going to be plane 5. Notice how the Z is facing the wrong direction. I want to flip that direction. And we have that preview window, and on the right side we also have the preview window, and that looks good to me. I'm going to accept that. I'm going to hit Control F to bring it into the scene. Now that we're aligned, we can delete these planes. Those were just used for the alignment. And we can come in and notice that the origin is in the right place. Now that I'm aligned to the world, I can use my perpendicular views. A cool tool I want to show you guys is called Separate Point Cloud. And that's in the Points tab under Separate Point Cloud. And what this does is it takes a single point cloud and divides it into several groups. This is nice when you want to separate an area of interest. I'm going to have Remove Original Data turned off. And I'm going to come in and draw my grid. These are customizable by left-clicking and dragging. Say OK. Now that I have my groups made, I can show you by hiding them. This makes it a lot easier if I have a certain area that I want to model. I can jump to it pretty quick. I'm actually going to turn off the groups because now we're going to model the side walls of this room. I'm going to come into my Sketch tab. I'm going to turn on my planes. I'm going to say Mesh Sketch. I want it to be the front plane. I'm going to take a section of the room. Let's say 50 inches high. Say OK. Turn off my point cloud. Come into my line tool. And start making these walls here. I don't have to connect them all at the moment. I'm going to do a corner trim. And I'm using the poly line to snap to. And I didn't get the best section here, but for time's sake, let's say that's okay. I'm going to come into corner trim. I'm going to trim those guys. If you notice these teal looking nodes, that means that I have a disjoint end, and that's over here in the analyzer. I can turn that on and off. But I'm going to keep going and complete this profile of the ship's room. And you can either click and drag or click on the next one that you want. Both ways work. I don't have any more disjoint ends. I'm going to say OK. I'm going to exit this sketch. I'm going to go into my model tab. And I'm first going to extrude the floor. I'm going to say that's about 3 inches. Say OK. And now I want to extrude my sidewalls. I have my profile. And I'm going to turn my point cloud on to roughly see how high I need to go. Let's say 100 inches looks good. I'll say OK. I'm going to turn off my point cloud again. I'm going to thicken surface. I'm going to give it about a 5-inch thickness. Either one of these tells me which direction. And I'm going to say OK. Real quick, I have now solid room data, and I can keep building. So now that I have that modeled, I'm going to turn my point clouds back on. And I want to show you how fast it is to model something inside the room. If I turn group 1 on, I come in, and let's model this chainstay here. I'm going to turn that on, and I'm going to basically highlight that. Over in the right view, I'm going to say set as view clip, say OK. I'm going to come in here and say I want to make a vector. I'm going to say that is a cone axis. Come in and highlight that. I have to make sure select through is off or is on. Highlight that. I can preview it. For this purpose, it looks okay. Now I can come in and make a plane off that vector. Pick point and coplanar axis. I have to pick a vertice. I say okay. Now I can come back into my mesh sketch and make a sketch off that plane. Once I have that sketch, I can make a revolve and do other things like that. For the purpose of this video, I'm running out of time, so I want to show you the pipe wizard. I'm going to exit out of this. I'm going to set my view clip back so I see all. Open up my point cloud. I'm going to orient my point cloud so I can now just show the roof here. I'm going to highlight the top. Say I have to have that turned off again. Select through. Say make that the point. Make sure that's the roof. And really quick, I want to show you how fast we can get data on one of these pipes on the ceiling. Let's do this pipe right here. I'm going to go into my Home tab, turn on the pipe wizard. I'm going to say cylinder selection. And I'm just going to start taking points on this pipe. I can say check to see what I have so far. You can always add to it. I can come in and say okay. And that looks pretty good. If I come in and turn the target off, I can then delete this overspray by holding control. That usually doesn't affect too much, but it's good to know that it's there. And then I want to preview it. So let's preview what we have. And really quick, I can have pipe geometry just by selecting a few points. I want to cap ends, and then this will turn that into a solid. And let's say okay. Turn on my solids. Really quick, I have some data going. Thank you for stopping by today. For additional resources and more information about software, applications, and solutions, you can visit 3dsystems.com